match up with
It's
the
might be difficult.
that means the zeroth term should equal 0, right? If you put the zeroth term for this is not equal to 0.
Okay, should I go over number 2 or number 3?
No,
Yeah.
it's 1, 3, 5.
Okay, I'll go with number 1 first. Number 1's fairly easy. I'm gonna talk about a second way to do it. Okay, I'm gonna talk about a second way to do it. So with e to the 2, number 1's f of x is equal to e to the 2x. Go ahead and take fourth derivative. You're gonna get 2e to the 2x. Now this is the first way to do it. This is the first way to do it. Do a second way to do it. I'm gonna show you a second way to do it because that's gonna be about what we're gonna do today. So e to the 2x, f double prime of x equal to 4e to the 2x, which is 2 times 2. I'm gonna write down 2 to the second power. Is that okay? After the third derivative, that is gonna be 2 to the third power e to the 2x. F fourth power is gonna be 2 to the fourth power e to the 2x. Now f prime of 0 is 2. F double prime of 0 is gonna be 2 squared. And the f triple prime of 0 is what? 2 to the third. F fourth of 0 is gonna be 2 to the fourth. Now we're gonna write out the first term. What's the f of 0? F of 0 is what? F of 0 is 1. That's a 0 factorial. X to the 0. So that's going to be, that's equal to 1. Now what's the second term? F prime of 0 is equal to 1 factorial. So that's equal to 2 over 1 x, right? And f double prime of 0 of 1 factorial is going to give you 2 to the second over 2 factorial of x to the square. Is that okay so far?
Yeah.
Now, I'm going to do one more. I'm not going to do another one. So 2 to the 4th x, 2 to the 3rd x to the 3rd over 3 factorial. Then you can see that that's going to be 2 to the x to the n over n factorial, and n equal to 0 to infinity. Now let's talk about second way to approach it though. Second way to approach it, you should already have memorized what is e to the x, right? E to the x is a summation of what? N equal to 0 and infinity. And then it's going to be x to the n over n factorial. This is one thing. So the second way is actually pretty easy. Do you see here? This is x, right? Can I just replace that e to the 2x? So if I replace this x to the e to the 2x, guess what? It's the summation n equal to 0, infinity, it'll be 2x to the n of n factorial. You replace the x with the 2x. And that's a very useful thing to do because you can
E to the 2x to the n? Oh, okay.
yeah, to the 2x to the n. So you can just replace that x with 2x. You can replace, so if you have a for sure power series, right? If you have decided to have a square root x, you can replace all the x area with the square root x. That's gonna be the same of each side. You can, it's like composite. So you can replace that x with the square root x or replace with the x squared. Now you're not able to replace with natural log of x because that's not gonna work. You can only replace x to the certain power just because you can plug in to something. You can replace that x with something else. Yes.
So what if there's a coefficient, like if it's 2 to the 2x, then what happens?
2e to the 2x. Later on, we're gonna talk about another situation. That one, that's just a constant. We can multiply it. So the best way that we're gonna do it is probably do using the sine square of x, for example. We're gonna find a way to replace. We're gonna find a way to produce a power series of sine square of x. But you have to add each individual part, each inside. But we're gonna do that in a second. But yeah, you can replace something. Now, why is this answer is most of you guys got square root 2 over 2. It's not a problem because sine, cosine of anything of pi over 4 is always square root 2 over 2. You can take it in front of the summation. But the problem is this. I didn't teach this yesterday, and it's my fault. But if you think about it, n to the n plus 1, if you think about it, it's negative 1 to n. So imagine this is a way to set negative, negative, positive, positive, or two consecutive signs. Yeah, over 2. Oh, yeah, right, over 2. So there is a consecutive sign. You can try it. Try to plug in n equal to 1. What happened n equal to 1? Is 1 times 1 plus 1 over 2. And that's just 1, right? So that's going to be negative. It's negative 1 to the n, right? So n equal to 2 is going to give you what? 2 times 2 plus 1. And 2 cancel out. That's equal to 3. That's still going to be negative. N equal to 3, n equal to 4. Hopefully they are positive, but we're going to try it. So it'll be 3 times 3 plus 1 over 2. So that is going to be, this cancel out to 2. That's 6. That becomes even. Yeah. So, and it's 4 times 4 plus 1 to the 2. So that is going to be 2. That's also even. Do you see like even, even? This is a way to adjust that even. If you don't believe me, let's try n equal to 5. Hopefully they are going back to odd. So it'll be 5 times 5 plus 1 over 2. So this is a 6. This is 6. 6 and 3. That's 3. 3 and 5 is 15. That becomes odd. So it will hold on all the places. Now I didn't explain this yesterday. It was my fault. But I know Jared was only one that actually go look it up. How do I create negative, negative, positive, positive? There is another situation can make it negative, negative, positive, positive, which is we're going to talk about later. If I'm trying to prove, let's say, Euler's formula, which is the most well-known formula in the world, it's also known as the most beautiful equation in the world. You have to understand that negative, negative, positive, positive can occur in another pattern that's deal with i's. Okay. I is going to give you negative, negative, positive, positive. Think about I to the first power. I think about I to the 0 power, I to the first power, I to the second power, I to the third power, I to the fourth power. So that's another situation you can get negative, negative, positive, which is later on we're going to show you the proof, which is not going to be on AP exam. So none of this, because and to get to the point that this is probably going to be the last math class you ever take. For a lot of you guys, this is going to be the last math class you're going to take. Or for beta, probably going to be the last math, right? You don't need any other math after this. Oh, you won't do a computer engineer. You might do more. But for Devin, this is the last one because he want to be a surgeon. Neuroscience. You don't need a Calc 2. Yeah. Yeah, not everybody need a Calc 2, so this is going to be the last one. So we're going to talk about the beautiful part of the math, which is that's going to be more interesting. Rather than just only focus on that 2 or AP exam. You got to learn to appreciate math in that perspective, I feel like, because a lot of students that just understand like how do I take a test. But the real beautiful part of math is usually not on the test. But we will show you that the next time.
Usually the ugly parts.
Huh?
Usually the ugly part.
Mm-hmm. Now today, I would like to tell you, like I will show you the video.
That's about 107.
Mm-hmm.
Because if you like plug in that new summation, the new series you just made, you get the first one to be x minus 1. But if you plug into your original thing, like f to the power of n of 1 over n factorial times x minus 1 to the power of n, the first term is 0. So they're not like matching up.
You have to, okay. What's your answer? Because it depends if it starts at 1 or 0.
I know, but why can you like look? So this is the original, right?
Yeah.
So the first term is 0.
Yes.
But if you plug it,
Okay,
in,
moving on to
this
today.
first term is x minus 1.
No, today I just want to show you a video.
Look, so yours is
And what is-
starting at 0.
What is it called?
It's a shape.
I just want to show you a video about how things work.
Is it the actual guy, the Bernstein guy? Professor Leonard?
It's supposed to start at
If you start
it can't start at 0 because n cannot be 0.
it's n plus 1 on the bottom.
No,
What did
so when you just use this to get your answer and cancel stuff out, you end up with that, but that has to be
Okay, but still, it doesn't make it. No, but look, it still doesn't make sense. Let's say you plug in n plus 1 to this one. You get this, you get x minus 1. If you plug in n plus 1 to this one, you get that. How does that make, but they're not equal. You're saying this is the same thing as that, but it's not.
It's a translation, like the sine and cosine, it's like Shelly, there's no way to prove it. There's no way to prove what you say. It's just, it's a translation.
Oh, yeah, that makes sense.
Okay, on a school computer.
It doesn't still equal the same thing.
Let me see if I can. Huh? Can I download VPN on my computer? Is it locked? No, I need to find a way to get things.
Wait. At the Navy, you have to do like training classes, like military training classes every day. I said I'm going there for 6 weeks. They gave my head. I'm doing that every day. And then I do it throughout the year. Before? Yeah. No, I'm saying throughout the year. Oh, yeah.
And class was crazy.
They shave your head?
Oh no.
You have no red hair? No. Only for freshmen. Oh, only freshmen. But it's like buds or like a little shape lamp? Dang. Everyone's buds?
Maybe you should go to Naval Academy.
Now, if I got an Naval Academy, I'd be always from. Or if I don't see Joe.
Bro, I can have you.
Dude.
No, I can see Michael with the buzz.
That'd be raps.
For a better buzz, man.
No.
If I pay you, Anchorman now, did you
They
get
mean
buzz?
$1 million. That's actually crazy. 6-week trip. What is that training include?
Legs.
Legs.
Oh, it's a boot camp at the Pro.
Like workouts? Yes, that and like just like go to college. Yeah, it's 13.
Maybe.
I got a little bit of that.
Okay, I might download XBPN, see if it works.
That's one that.
Yeah.
It's not the.
You get to yell at them back. You get whooped. You have to sign a contract like you're allowed to get spanked.
Why are you so interested in the dominatrix? Bro. All the way.
Same different.
He's gonna be over here by that time. It's a problem. So, like, how open? You have to like, it's not gonna happen. I'm sure that you're not gonna. You have to fight.
Yeah, you have to
Earn a turn right to go to class. Are you gonna do that? That's tough. You need class left.
Yeah, you know,
There's like,
why do you want?
you should do that, bro.
So literally just Fortnite.
All right.
Bro, like, what's the point?
Peter.
Yeah, about me. Yeah.
You get it, Mr. E?
Yeah.
Wait, what
Thanks
are
for
What are those things called? What are those things called? My down?
Video is about the ridiculous way to calculate pi. For 2 decades, the most successful method was painstakingly slow and tedious. But then Isaac Newton came along and changed the game. You could say he speed ran pi, and I'm going to show you how he did it.
Someone
But
should like
first, pi with crust off a pizza and lay it across identical pizzas. And you'll find that it goes across 3 and a bit pizzas. This is pi. The circumference of a circle is roughly 3.14 times its diameter. But pi is also related to a circle's area. It's just pi r squared. But why is it pi r squared? Well, cut a pizza into really thin slices. These slices into a rectangle. The area of this rectangle is just length times width. The length of the rectangle is half the circumference because there's half a crust on one side and half on the other. So the length is pi r. And then the width is just built of a piece of pizza. The original circle. So area is pi r times r. Area is pi r squared. So the area of a unit circle then is just pi. Keep that in mind, it can come in handy later. So what was the ridiculous way we used to calculate pi? Well, it's sort of the most obvious way. It's easy to show that pi must be between 3 and 4. Take a circle and draw a hexagon inside it with sides of length 1. A regular hexagon can be divided into 6 equilateral triangles. So the diameter of the circle, now the perimeter of the hexagon is 6, and the circumference of the circle must be larger than this, so pi must be greater than 6 over 2, so pi is greater than 3. Now draw a square around the circle. The perimeter of the square is 8, which is bigger than the circle's circumference, so pi must be less than 8 over 2, so pi is less than 4. This was actually known for thousands of years, and then in 250 BC, Archimedes improved on the method. So first he starts with the hexagon, just like you did, and then he bisects the hexagon to a dodecagon, so that's a 12-sided, regular 12-sided shape, and he calculates its perimeter. The ratio of that perimeter to the diameter will be less than pi. He does the same thing for a circumscribed 12-gon and finds an upper bound for pi. The calculations now become a lot more tricky. Extract square roots and square roots of square roots and turn all these into fractions. But he works out the 12-gon and then the 24-gon, 48-gon, and by the time he gets to the 96-gon, he's sort of had enough. But he gets, in the end, he gets pi to between 3.1408 and 3.1429. So for over 2,000 years ago, that's not too bad.
Yeah, that seems like all the precision you need in pi.
Right, so this goes way beyond precision for any practical purpose. This is now a matter of flexing your muscle. You know, this is showing off just how much mathematical power you have, so you can work out a constant like pi to very high precision. So for the next 2,000 years, this is how everyone carried on, bisecting polygons to dizzying heights. As pi passed through Chinese, Indian, Persian, and Arab mathematicians, each contributed to these bounds along Archimedes' line. And in the late 16th century, Frenchman Francois Viette doubled a dozen more times than Archimedes, computing the perimeter of a polygon with 393,216 sides, only to be outdone at the turn of the 17th century by the Dutch Ludolf van Ceulen. He spent 25 years on the effort, computing to high accuracy the perimeter of a polygon with 2 to the 62 sides. That is 4 quintillion, 611 quadrillion, 686 trillion, 18 billion, 427,387,904 psi. What was the reward for all of that hard work? Just 35 correct decimal places of pi. He had these digits inscribed on his tombstone. 20 years later, his record
That's a true definition of person with no life.
He got 38 correct. But he was the last to do it like this? Pretty much, yeah. Because shortly
So
there,
you didn't see how collapsed his hairline was?
his message. Nobody is bisecting any god ever. The year was 1666. Newton was just 23 years old. He was quarantining at home due to an outbreak of bubonic plague. Newton was playing around with simple expressions like 1 plus x all squared. You can multiply it out and get 1 plus 2x plus x squared. Or what about 1 plus x all cubed? Well, again, you can multiply out all the terms and get 1 plus 3x squared plus x cubed. And you could do the same for 1 plus x to the 4 or 1 plus x to the 5 and so on. But Newton knew there was a pattern that allowed him to skip all the tedious arithmetic and go straight to the answer. If you look at the numbers in these equations, the coefficients on x squared, and so on, well, they're actually just the numbers in Pascal's triangle. The power that 1 plus x was raised to corresponds to the row of the triangle.
Right, and Pascal's triangle is really easy to make. It's something that's been known from ancient Greeks and Indians and Chinese, Persians. A lot of different cultures discovered this. All you do is, whenever you have a row, you just add the two neighbors, and that gives you the value of the row below it. So that's a really quick, easy thing. You can compute, the coefficients for 1 plus x to the 10 in a second instead of sitting there doing all the algebra.
The thing that fascinated me when I started looking at those old documents was how even, I don't speak those languages, I don't know those number systems, and yet it is obvious, it is clear as day that they are all writing down the same thing, which today in the Western world we call Pascal's triangle.
That's the beauty of mathematics. It transcends culture, it transcends time, it transcends humanity. It's going to be around well after we're gone, and ancient civilizations, alien civilizations will know Pascal's triangle.
Over time, people worked out a general formula for the numbers in Pascal's triangle, so you can calculate the numbers in any row without having to calculate all the rows before it. For any expression 1 plus x to the n, it is equal to 1 plus n times x plus n times n minus 1 x squared on 2 factorial plus n times n minus 1 times n minus 2 times x cubed on 3 factorial, and so
Does that look
And
familiar?
that's the binomial theorem. So binomial, because there's only two terms, 1 and x, phi is 2. And theorem is that this is a theorem that you can rigorously prove that this formula is exactly what you'll see as the coefficients in Pascal's triangle.
so it was known in Newton's day already.
Yeah, exactly. Everybody knew this. Everybody saw this formula. And yet, nobody thought to do with it the thing that Newton did with it, which is to break the formula.
The standard binomial theorem insists that you apply it only when n is a positive integer, which makes sense, right? This whole thing is about working out 1 plus x times itself a certain number of times. But Newton says, screw that, just apply the theorem. I mean, math is about finding patterns and then extending them and trying to find out where they break. So he tries 1 plus x to the negative 1.
So that's 1 over 1 plus x. What happens if I just blindly plug in n equals negative 1 for the right-hand side?
And what you get is the terms alternate back and forth. Plus 1, minus 1, plus 1, minus 1, and so on forever.
So that's 1 minus x. The next term will be a plus x.
Does that look familiar? What is this?
Negative 1 to
No. What is that?
no.
Yeah, 1 over x. Is it not the same thing that we did here?
Number 5.
Remember what's 1 over 1 minus x?
Oh,
What is that called?
you mean like besides the fact that it's a geometry series?
Yeah. It just replaced the x with negative x. Do you remember that? Remember that last time we saw this is 1 plus x squared plus x to the third plus x to the fourth? That's 1 over 1 minus x. This one's 1 over 1 plus x. Just replace that x with negative x. Does that make sense?
Yeah.
The next term will be a minus x cubed plus x to the fourth minus x to the fifth. So it's just alternating series with plus minus x as the coefficient.
So it becomes an infinite series.
Yeah, that's right. If you don't have a positive integer, the binomial theorem, Newton's binomial theorem, will give you an infinite sum.
But how do you understand that? Like for all positive integers, it was just a finite set of terms, and now we've got an infinite set of terms.
Yeah, so what happens is if you have
Does that look like
positive
Taylor
integer,
series?
remember that formula, the coefficient looks like n times n minus 1 times n minus 2 and so on. When you get to n minus n, if n is a positive integer, you will eventually get there, and n minus n is 0. So that coefficient and all the coefficients after it are all 0, and that's why it's just a finite sum, finite triangle. But once you get outside of the triangle with positive integers, you never hit n minus n because n is not a positive integer. So you get this infinite series.
So I think the big question is, does this actually work? Does Newton's infinite series actually give you the value of 1 over 1 plus x?
Right, and it might be nonsense. There's lots of math formulas that break completely when you do this, right? We have rules for a reason, but we should always know the extent to which the rules have a chance of working farther. If you take that whole series and you multiply it by 1 plus x, and you multiply all that out, you'll see all the terms cancel except that leading 1. And so that big series times 1 plus x is 1. In other words, that big series is 1 over 1 plus x. That's how Newton justified to himself that it makes sense to apply the formula where it shouldn't be applicable.
So Newton is convinced the binomial theorem works even for negative values of n, which means there's more to Pascal's triangle. Above the 0 row, you could add a 0 and a 1 that add to make that first one. And then that row would continue minus 1, plus 1, minus 1, plus 1, all the way out to infinity. And you know, outside the standard triangle, the implied value everywhere is 0. And this fits with that. The alternating plus and minus 1s add to make 0 everywhere in the row beneath them. And you can extend the pattern for all negative numbers. Either using the binomial theorem or just looking at what numbers would add together to make the numbers underneath. And here's something amazing. If you ignore the negative signs for a minute, these are the exact same numbers arranged in the same pattern as in the main triangle. The whole thing has just been rotated on its side. But Newton doesn't stop with the integers. Next, he tries fractional powers, like 1 plus x to the half.
So now what does it mean? You take 1 plus x to the 1/2. Well, that's the same thing as square root of 1 plus x. And he wants to understand, does that have the same expansion?
Putting n equals a half into the binomial theorem, he gets an infinite series. And that makes me think that we could actually go into Pascal's triangle, blow it up, and add fractions in between the rows that we're familiar with.
Exactly. There's even a continuum of Pascal's triangle. Between 0 and 1, there's this, a continuum of numbers that you could put in for powers.
You can think of each fraction, like a half, a quarter, a third, as existing in its own plane, where in each plane, pairs of numbers add to make the number beneath them. N doesn't have to be a positive integer anymore.
Doesn't have to be a positive integer, doesn't have to be a negative integer, doesn't have to be an integer. Now we're going to take n to be a half. And he works this thing out, and then he can do all kinds of things. For example, he could work out the square root of 3 very quickly and efficient. Because the square root of 3, we can write 3 as 4 minus 1. And if we pull out a 4, then we get a square root of 4, which is just 2, times the square root of 1 minus a quarter. If you put in minus a quarter for x in this series, you'll get a very rapidly converging series expansion that will quickly give you square root of 3 to high accuracy.
Now, Newton is particularly interested in n equals a half, because the equation for a unit circle is x squared plus y squared equals 1. And if you solve for y, well, the top part of the circle is equal to 1 minus x squared to the half. This is basically the same expression he's been looking at, he just has to replace x by minus x squared, which adds in some minus signs and doubles the power of x on each term. But now he's got an equation for a circle where each term is just a rational number times x raised to some power.
Now we have two different ways of representing the same thing. And whenever you have something like that, magic is about to happen. Fireworks is about to go off.
But how does he use this to calculate pi?
Well, luckily for us, he had just invented calculus, or what he called the theory of fluxions. He realizes that if you integrate under that curve as x goes from 0 to 1, you're getting the area under the curve, which is a quarter circle. And he knows that the area of a unit circle is exactly pi r squared, except r is 1, so the area is pi. And we want just a quarter, so the area is pi over 4. On the other side, he has this nice series, and he knows how to integrate x to some power.
You just increase each power of x by 1 and divide by the new power. And now you have an infinite series of terms which just involve simple arithmetic with fractions. You put in x equals 1, and you can calculate pi to an arbitrarily high precision. But Newton goes even further, adding one final tweak.
A not good math paper has 0 ideas. It's just pushing through things that everybody already knows, but nobody bothers to do. Then there are good math papers that have like one new idea that's like really shocking. Newton's on new idea number 4 at this point, and he's about to have new idea number 5. Idea number 5 is instead of integrating from 0 to 1, he's going to integrate just from 0 to a half.
You know, when you have an infinite series, you want the terms to decrease in size as fast as possible. That way you don't have to calculate as many of them to get a pretty good answer. Newton sees if he integrates not from 0 to 1, but from 0 to a half, then when he subs in a half to x, each term will shrink in size by an additional factor of x squared, which in this case is a quarter. But if you only integrate to a half, what is the area under the curve that you're computing? Well, it is this part of a circle, which you can break into a 30-degree sector of the circle, which has an area of pi on 12, plus a right triangle with a base of a half and a height of √3 on 2. So that integral should come out to this expression. And rearranging for pi, you get the following. Now, if you evaluate only the first 5 terms, you get pi equals 3.14161. That's off by just 2 parts in 100,000. And to match the computational power of Van Curlen's 4 quintillion-sided polygon, you would only need to compute 50 terms in Newton's series. What before took years, now would take only days. So no one was bisecting polygons to find pi ever again.
Why would you? Yeah, you do all that work and somebody fucking beats you in a second. It's sort of like, you know, once someone builds a crane, and somebody else is still climbing up on a ladder to put a brick on it. That's just not how you build houses with new technology. Are you out of your mind? You're gonna, you know, we're gonna build a 100-story house. You're gonna build a 5-story thing that's gonna fall over. You see it in New York City. You see literally where technology came along. There's like rows and rows of 5-story buildings, and all of a sudden, here's a 20-story, and here's a 30-story, and here's a 90-story. So it's all about who has the technology.
For me, this is a story about how the obvious way of doing things is not always the best way. And that it's often a good idea to play around with patterns and push them beyond the bounds where you expect them to work. Because a little bit of insight in mathematics can go a very long way. Hey, this video was sponsored by Brilliant, a website with interactive.
Okay, so hopefully you see a lot of things that deal with what we're doing here, and they are infinite series. You can using that to approximate a number, much more efficient in just dissecting a polygons. Okay, so I know that you might feel bored about this, but this, some of you guys, maybe 1 or 2 or 3 or 4 or 5 of you guys will get to the level where you're gonna come back and explain to me how math works. So have a good Friday. Next week we're gonna spend the whole week just talk about Taylor series. By end of the week we should be able to give you a test. What? Oh, I'm so sorry. When is due? Today?
It really gave me auto reply at the bottom of it. It said, yeah, I got it.
I don't know which computer I store it, so I gotta find it. But it should be one of my laptop or my computer. Oh, I mean, look. Oh, okay, okay. I'll send it to you. Remind me if I did. You just text me. It'll be faster. I don't read email. You guys should know I don't read email. So it's no point of email me. That's gonna be buried under the pile. Okay. Send me a text if you faster. I know you send to me, I just forget. But just keep on harass me. It's okay. You have permission to harass me. Okay, Jared's gonna teach you how to do Taylor series. Yeah, the same. One just easier than the other one. You too. They both are hard, but it's scary to look at first. How's MPA?
Oh, I didn't go.
You didn't go?
Just.
Oh, but what were you yesterday? People say you have MPA.
I slept.
All right. I won't get to take it serious.
No, I didn't know what we were doing. Busy. Still locked. That door. Yeah. Was there anything else? Yeah. It lasted 2 hours. Of course, it was more. First time, man. Only like. Low-key overrated. I'm not gonna lie. You got more out of it. See.
I told you, Kelly's gonna be part time.
Yep.
Yep. Ask Tony. But it's okay. You and who else playing ping pong?
Me and okay, it was Sheldon, Anthony, me, and
Sheldon and yeah, who screwed up the who screwed up the ping pong table?
I didn't.
Who?
I don't know. It was when I left. I left.
So Yulia come and talk to me. He's like, I'm sorry, I messed up your ping pong table.
What happened?
When they opened it up, I don't know who opened it up. Anthony, were you the one mess up my ping pong table? Huh. I know one of you guys did. No, Yulia's pretty cool about it. She come in and said, Miss G, I'm so sorry. And
I respect that.
yeah, I respect.
Yeah, what's messed up though?
I don't know. Ask Anthony.
Like what?
Ping pong table.
Like when we opened it up, the only thing that kind of got ruined was just like the board got a little scratch, but that was their last time. Like it was the same scratch.
No, she said there's another one.
Like already played?
Were you the one opening it up?
Yeah, I opened it up, but I didn't scratch it.
Where's the scratch?
I don't know. Well, Yulia told me, says, I'm sorry, you scratched your ping pong table. I didn't know what it was about, and I was like, oh, okay. That's not probably not a big deal.
It's not like nothing is broken or anything. It's just like
She said that you guys don't know how to open it.
hey, I knew how to open it. Right?
Mm-hmm. But it's okay. I'm not upset. I'm just like, whatever. I told you, ping pong is Friday only. Not any other day. Ping pong only.
It was your mom.
Friday only.
Friday only.
Friday ping pong day.
Friday ping pong day, yes. That means today.
Today is Friday.
But today I gotta leave early though. Yeah. My wife, my son's sick. My wife needs somebody to pick up.
You make your kids go to school when they're sick.
Huh?
You make your kids go to school when they're sick.
Depends.
Yeah, my mom be making me, because I think towards the beginning of the year, or like last year, I kept pretending to be sick so I wouldn't have to go to school. And then she caught on to that, so now anytime, even if I am like actually sick, like throwing up and stuff, she'll still make me go to school.
That's why you don't play that game.
Yeah.
Oh,
It's super prizes involved.
That's why you don't play that game.
that's fine. Dude, I can't wait to be completely independent. 3 months. Self-sufficient.
By then, you're gonna find that there's different set of problem.
I'll be fine. I know how to do it.
Okay.
I'm very flexible. I just need space to like cry. You know, I can't have people like crowding me. What? Oh yeah.
All right, Jared, would you mind teach Rebuff how his Taylor series work?
Oh, actually, yeah. No, I got this. All right.
And we're not doing anything serious, so we are watching a video that's pretty interesting. That involved with the power series.
Log in for a second. The word was in 3.
Yeah.
3, I got. Like, I had to look up how to make it like every 2.
Yeah, it was crazy. I was trying it. It was like 2 pi n plus pi.
You gotta do an answer plus n over 2, which is weird, but it works. Yeah.
My code.
Pi, what did you say? I think somebody tried that last year.
It was. I was trying to use cosine to make it.
I think he's using the pi.
Shut up. Watch.
Yeah, I was using cosine to make it switch, but I was just for a while actually. I was thinking about what angles. But it's,
Are you okay? Very well. Don't skip my class, man.
Me?
Yeah.
No, I wasn't skipping your class. I was skipping my last 2 periods. Your class just happened to fall into that category.
What?
What if you did like, value of cosine of
Jared's gonna start cooking.
X over normal cosine of pi. Right? Would that work for like
Hold on,
every
let me-
other X?
I need
I
to
think
see.
it's when you put in zero though. It'd be
I need to see this.
Well, you can't use cosine.
Yeah, your power series is all internal polynomial, right?
This is in the X. Oh yeah, but that would kind of like defeat purpose.
That's what I did.
Is that what you did?
He did that.
close. Oh, it's like three pi over 5n. Like it works for the first few.
It works.
This is like probably the hardest shit. Like,
But that would be like.
It's not Austin. It's not even hard. It's not hard. Stop bullshit.
it's not. But like, it looks like a lot. It looks like a lot better.
Shit, it would be zero.
A lot of
it would be-
information, but it's not hard.
Yeah. That's the problem. No, like apparently it was this.
Almost.
Yeah.
It's just
How will you know that? How will that go from positive negative negative positive?
well, I mean,
N times n plus 1 over 2.
3, 1, you have 2 over 2, which is 1, 2, you have 4 plus 2, you have 4 plus 2. 6 over 2 is
3.
3.
Well, it has to get negative somehow.
No.
Because it's negative 1 to that power. It's negative 1 to that power.
Oh, I'm sorry. I thought you just wrote n. I think I was reading on.
12 over 2, 6, 4, 20 over 2, 10, 5,
Now let's put like cosine pi of.
So these two are odd, each are odd, and keep going.
Oh, yeah, yeah. No, I didn't realize you had this. I thought you just did this. I was like, how's that?
No,
going?
no.
Did you look up why that is?
I mean, it should work.
Yeah, but why that is?
This was another way. I think it was cosine.
I did not.
It was like 2 pi n plus pi.
What's the one?
Oh, that's not. No, I did absolute value cosine of something of pi over 2x over no absolute value of something. But it gets 0 from that. 0.
This is what I tried to use solution in. Now flip between
N equals
1, negative 1, negative 1, 1, 1.
I think that's what we did.
Yeah.
I didn't get it here, but that's what I was trying to do. But I think that's the way. Oh, and that's not me.
Well,
Yeah.
exactly. Inventing cool math.
But yeah, the n2 plus n over 2 is. I think it's true.
We're not learning anything.
We are gonna look at the video.
Wait. I need to leave the feed.
It might take all class.
Teaching him?
Mm.
No, it's not. He's smart.
Well, I want to go over at least like one of the homework problems just to like demonstrate.
We need 20 minutes to watch the video.
Bro, are you changed now?
I
Be meeting my children. After what was that?
think it's like Swedish.
Oh. Yeah.
Yeah.
No,
Nice.
I'll feel the same. I'll feel the same, but like.
Got it. 15 grams.
Hey, did
Right?
Jared, I was wondering if I can ask you something. Probably gonna make you feel.
That's fine.
What is your perspective in as a Gaza Strip?
I mean, I don't follow it too closely, so I don't really have an opinion, like a educated opinion at least. But, I mean, the whole situation in general is just terrible. I'm not really for either side. I mean, I'm definitely not like anti-Israel, but I don't think.
When you
that
are,
it should-
yeah, you are.
Right. So like obviously I support Israel, but I don't support just the complete destruction of like Palestine and Gaza Strip. Like I think that's terrible as well. I don't really think there is a good solution.
Don't worry about political correctness.
But,
Just,
yeah.
I understand.
And just trying to-
Wait,
Yeah, I'm not gonna cancel.
why do you ask? Like, what about? Are you Jewish?
I'm Jewish, yeah.
Oh,
And it's not like, you're supposed to like be on a, like, the other side, or else like, you ain't gonna.
Oh, yeah.
You can't be on like, in the middle, right? But I was like, you're still gonna.
Like, I have family in Israel, and obviously I think they should, like, I think they have the right to feel safe in their homes. And I think all the, like, terrorism and Hamas and Hezbollah and stuff with going into Israel and all the acts that they're doing there is terrible, but nice.
No, the reason why I asked Giovanna,
He's
you're
very,
very passionate.
very passionate about, but yeah.
And she almost like,
He's very pro-Palestine.
she's like, she almost cried when I talked to her. I was like,
I don't get why. Like,
No.
what connection does she have to? Because she's extremely.
She's Italian.
She's Italian or Brazilian?
this is probably like the,
She's half Italian, half Brazilian, but she's like the most passionate person about this subject.
I know, I was like, I didn't know about it, and one day I was like, well, I guess I was saying exactly like same thing you said. I think people should be safe, not gonna be terrorists. And she's like, oh, they're being terrorized by the US country. And I was like,
'Cause, like,
I'm so sorry.
You know Omar?
Yeah.
The buff one?
Yeah.
Because he's Muslim. And I don't know if he's Palestinian, but he's from somewhere around there.
But not,
So, like, he,
him, I understand. He's from Jordan. Jordan.
well, not like it have to be a draft opinion on it, but like, it's just, I'm just curious, like, why she is so passionate about it. But like, I've talked to him about it, and we've had like civil conversations about stuff. And I had him, I sit next to him in physics, and Mr. Greenwald is our teacher in that class, and Mr. Greenwald is, or at least one of his parents was Jewish, I think, so he kind of identifies with that class. They kind of went at it for a day.
Oh, I didn't. When I heard, I didn't say anything because I'm just not knowing. Like, I guess, like, I don't want to go to concert and get hijacked.
Yeah. And I kind of, I kind of want to stay away from like learning about stuff in general, just so I can kind of flee that I don't know. Like, I don't want to be, like, seriously, like, I don't want to take a side that passionately, so I don't like.
No, I like how passion was like very.
Oh, no, she's yeah. 'Cause-
Is it like that series?
Oh yeah, they had like a current debate or current events meeting about the subject, and apparently she like I wasn't there, but I heard from people that she was just monopolizing the entire thing about the meeting, just like broke out something to Israel.
Oh yeah, that's what I was asking. But in general, I kind of want to be educated to see like.
Yeah, I mean it's good.
What is the thing? But I'm same like you. I mean, probably the more educated I am, probably gonna have to stand on one side, and it's gonna be pissed off the other side. And I don't.
Both wrong.
They
Yeah,
probably.
no, that's just like
Yeah, but that's why I say it both wrong. But she's
don't think-
like.
I don't think the ends justify the actions taken by either side. Like people are saying that like I don't know, like Omar's take, I kind of agree with him that he agrees Hamas is terrorists. Like Palestine as a whole, like as a country, they're not terrorists, but Hamas, the group running Palestine, are terrorists.
So he agrees with that.
Yeah, he agrees with that. But he also says that Israel, like the Israeli government, the Israeli military, are as much terrorists as Hamas is. Which
I kind of.
I don't know that I see that as much, but yeah, but with like some of the things that they've done, I definitely like understand the view.
Yeah, no, that's what. No, what I think is. What I think I'm gonna be say out loud, and I don't know if I'm gonna offend you, but I feel like Israel, the more they bomb the shit out of there, the more terrorists they create.
Yeah, because I mean the children.
That's me. The more you bomb the shit out of the country, the more terrorists you're gonna create. This is a law of disorders.
It's like outside, right? Like before they attack, before they get them out.
Yeah.
So
I
they
mean, the more
become terrorists.
the more they are passionate about.
So
I
Missouri series
get
is
back.
the same as Taylor series.
And it's just a bad cycle.
There's
But whether who started, I don't know. I don't know which country started.
It's real. It's the new one.
so FN.
It's really cool.
Function to the nth degree.
Oh, if you went anywhere in the country, why is it doing? Because it was after the Holocaust.
Wait, so I actually know. I don't know anything about this. So Britain put Israel like.
Well, I think it's Britain.
So Palestine existed, and then during I think it was either during or right after World War II,
Yeah.
Britain like told Israel that if they or the Jewish people that if they
Why
fought
the
over
Britain
Britain-
give a portion of their country? Like,
So
Well, that's what they did. So the Palestinian people lived there. And then Britain promised already Palestinian land to the Jews, the Israeli people. So then when they moved in, it was land promised to them by Britain, but Britain didn't have any claim to that land. So the people that were already living there got kicked out, and that's why they're
would they ever peacefully live with each other? Like
And
before,
I mean that's the dream. Like that's the
no,
only.
before the
Before they didn't have it all.
They were kind of
Like,
like,
maybe like 1,000 years ago or 2,000 years
but
ago.
don't like is Jesus Jewish?
Yeah,
was,
he's Jewish. He's Jewish, and then.
But so he's from there, right?
yeah,
Yeah.
right.
So that's
So
why.
Israel was basically like the promised land for the
Yeah.
Jews.
Yeah.
Like
Right,
under
it's the
God.
promised
No, before the World War II, before the World War.
Yeah.
Well, in both religions, like that area geographically is
Christian,
promised.
Muslim,
They
and-
both have like a religious claim to it.
Yeah.
Which is where the problems.
Yeah, Christians, Muslims, and Jews all have ties to that.
To what's it called?
Israel.
Not Israel, the Jerusalem.
Jerusalem.
I mean the whole like area is
Or
Israel.
in where?
No, I just want to ask because you're a Jewish person. I want to see like what is a Jewish person's perspective as opposed to. But I feel like she's kind of a lot,
You know, and
and I can't like
yeah, I don't know how open to other viewpoints she is.
no, she's not. She's like
Wait, sorry, are you Israeli now or just Jewish?
Just Jewish. I mean, like some people will say that like all Jews are like ethnically Israeli in like a religious sort of sense. Which I can understand, but I wouldn't consider myself Israeli.
Are you Ashkenazi?
I believe so.
What is that?
It's like ethnically Jewish, like you know, just
because I was watching. Not only that, I was watching yesterday. I was watching Chris Tucker interview Putin yesterday.
What? Really?
Yeah. No, it was very interesting, but also like you can tell like Putin's really good at propaganda. Like and he got a full setup of Chris Tucker is only like asking like a solve questions, and he claimed that Ukraine is a lot of Ukrainians support neo-Nazis, and which is it's interesting because I had talked to one Ukrainian girl from
This is
2 years ago. She is pro-Russian. Yeah, she's Ukrainian. She's pro-Russian, but she's on the side where it's closer to Russia.
okay.
And also Yulia, she's of course pro-Ukraine. And I talked to another boy. He's from Russia. He's pro-Ukraine.
Basically, the seven Sailor series.
Yulia is against Russia.
Alright, so you're in, you have
Yeah,
a
because he says grandma.
you're in dating Russian, so for example,
Yeah.
Yeah, he is Russian,
you have
but
a
she's
take the
not.
derivative of the function.
He's his grandma's?
Yeah, his grandma. Like the what happened in Russia is like a 24-hour TV, and then just like kind of bring it up. Grandma is all
Brain.
here.
Right now,
I'm staring at
But
that.
you're gonna plug in your
No, it's they just propaganda. And it's a first time interview, and so YouTube shutting down all the things that it's broadcasting.
Right.
First time
Okay, then we-
You thought I found out like a legal website.
No, I found out on this website. It was called Kevin. And
Okay,
so
this is
kind of
the-
like a breakdown of each thing. But he was really good. He was really good. He will make you believe that Russia has all the right to claim the Ukraine. Like he was
for the function, right? F of X, summation.
like he can convince you that it's all American law.
X
And but which is that's
This
like a very good.
function right here.
America has a lot of problems.
Yeah.
They are evil countries.
F minus C to the
It
N.
is true.
This is your very important.
But of course,
Okay.
I can see why YouTube had to shut down all the broadcasts as much as you can, but you can't shut down everything now, which is funny.
New function, e to the 2x. Alright.
Wait, let me copy this.
Alright. So what's the derivative of e to the 2x?
Get 2 years.
Okay.
Is that for tomorrow?
And the derivative of that.
That's a very shitty design.
What?
Yeah.
It's made by Hood Engineering.
What is it for? Boomerang or what?
It's like a windmill.
Put it on like a generator.
Really bad.
So we were supposed to make a wind turbine.
Well, like for side yeah, I guess.
Yeah.
How much?
So if this is 1, this is 2,
Uh,
this is 3.
I started last year.
Do you like it?
I feel like it's like an extra class on top of it.
It's like 2 to the.
Everything
Yeah.
else.
Well, first of all, you
F-
never
F-
turned
F-
your
F to the N
competition assignment last year because you were
is
lazy,
equal
right?
to.
That was last year.
Equal
This
to.
year you're gonna be on time?
Yeah.
Were you on time to USF?
Yeah. Hey, just on time.
Alright, and then you're going to plug in
Wait, then we think,
your
yeah,
second.
I mean, you were like, we're supposed to get there an hour earlier
Did they tell you this earlier?
so that he can register.
Yeah.
But-
Oh, it's not equal 0 for this one.
I guess we showed up a
Plug in
little
0
early,
for
like 30 minutes.
Where you from?
Like, like ethnically or what's is ethnically like? I don't know. But we'll just say like I have an Iranian passport and an American one, but like I was born in the U.S.
But what's your
Where your
religion?
parents from?
Well, like so my dad was born in Ireland, but he's Turkish.
Are you Muslim?
I'm pretty much completely American.
Are you Christian?
Yeah.
Okay.
Turkish is Muslim country, right?
But like I'm like I guess my blood is Turkish, but technically you say I'm from Iran now, and the US.
So yeah.
You grew up in either?
Yeah, I actually lived for 5 years in Iran.
Wait, which part?
Like northern.
So you moved from here to there and then back?
Yeah, but okay, I'll give you my last number. So I was born here.
Plug in 2
Super. I lived here in Indiana. Then I moved to Iran for 5 years.
First derivative, second
And I moved back
derivative.
here. Well,
Yeah, I hear you
So-
talk to Europe, you were actually in
Five
Ukraine.
years. And I lived in Ukraine there for like I've been in Ukraine many times. Yeah.
Why is that?
He was my uncle. Yeah. Obviously not the war story, but
Your dad's family is all Turkish.
yeah, but I mean they live in Iran, but like technically like,
Ancestry.
Yeah,
yeah, they're Turkish.
So F to the N of
So my mom
is equal
like
to 1.
Polish and American. So I'm like American, Polish, Turkish, and yeah, Persian. Yeah. Yes.
And then,
I was running as Iran and the US.
yes. So now you have
Yeah,
all your
You
values
have both
are
passports?
plugged into that one. So your
I thought you
academics.
cannot have both passports.
I think it has
dual citizenship.
it was citizenship, but
You
No,
cannot have
that-
passports.
oh,
No, you can't.
either.
Because I know people that have like a Korean passport,
You
like
do.
obviously because they have like the embassy here, so they can have a dual citizenship.
I know American don't.
No, I have. The Iran releases. I used to speak 3 languages. Yeah.
Used to?
Also.
I think it's good that. I'm good at that. Like they said, if you learn languages as a kid, like,
Sure. Yeah, same. We want-
Rayhan can speak a lot of.
Yeah.
that's cool. That
Yeah.
He's like,
That's it.
he's
Yeah.
so great because he knows like all the different facts.
You should be in like, what's that?
football.
Not the what?
Wait, that's the people you should recruit.
Oh, really? I don't know.
Is it German?
He's in junior.
He's a nice kid.
Yeah. Alright. So
That's
now,
lazy, but
Yeah, he's
not as lazy as Young. Young's the lazy. No, Joshua is more lazy than Young. Young is pretty lazy.
Ryan, he's pretty lazy.
Ryan is Joshua's more lazy than Young.
you hate on Josh too much.
Huh?
You hate on Josh too much.
He scored 7%.
Yeah.
He scored 7%.
Bad.
This whole CB's tearing apart.
Start this whole thing.
stand Josh for a long time, but now I think he's better.
Good.
Yeah. Is
What
it
is, I don't even know what he does like in his free time.
Josh?
Yeah.
I don't know.
He's very secretive.
He is.
Like he doesn't come to stuff. Like our friends will invite him to stuff.
Josh?
He rarely shows up.
Really?
Yeah. Like
I would go otherwise.
he comes to some stuff, but he's always doing his own thing. I don't know. It's a popular loner.
Really? Popular loner? This is the term for popular loner.
So can you write that and
Yeah.
It's this weekend, right?
Huh?
Yeah.
Do they have event on March 2nd?
No. I don't know what other events they have. Not sure. I think this is the big thing that Mr. Davis did.
You can't do that?
We don't.
I can't
Yeah, it's a tournament that we go to.
You're gonna be March 2nd, right?
Were you inside Sally last year?
yeah, plug in your center for this one is 1.
I'm looking at that one.
Seminole, I wanna.
I wish I went to Sonoma High School. It's really would be.
All of DJ kids.
Yeah.
Go to OSS.
I would have gone there too.
No,
Like,
OSS doesn't have two girls.
yeah, that's. No, no,
How would you know that?
I would.
Mysterium. How would you know that?
I know, because I picked up my kids over there.
Oh, you don't see any girls there?
It's all like a brown kid with the glasses and with,
Yeah,
It's
they're
like
not
copy and
really-
paste. It's like copy and paste.
yeah, like brown kid with glasses. Brown kid with the glasses.
Where is that like? How far?
The boys not looking, the girls not looking.
Are there cute girls at Olympia this year?
Yeah, you think the girls here are cute?
Hell no.
Okay, Bob, you have no spaces, dog. Out of anybody, you maybe out of anybody at the school.
But in OSS definitely.
Yeah, no, Sonoma High School. That's where I.
Really, you can use them.
Yeah, that's where like the.
I
There's
know.
no like jungle monkeys there. It's like all.
Jungle.
I thought we saw them in the math competition. They
I
all
think you know
weird,
what that means, though.
nerdy looking.
Yeah.
I think you know what it's supposed to mean.
They all nerdy looking.
I mean, they're not that big. Like, you gotta be in. Like, I went to the model event competition there for like one time. Like the girls there, they, you know, like they
PTA
make
girls?
themselves. Yeah.
Like, ninja bars.
Made with
Oh, and they're all tall. So like,
Save your bloodline. Do your math.
dude,
Plug
okay.
plug more math.
Yeah.
I think Mr. Davis's is winning, like the thing to measure it is like it's like broken, right? Like that junk, like it'd be wobbling when I'm like testing it.
But it doesn't fit well.
Yeah, because it's like loose. You tested it before, right? Or you've seen it?
Oh, yeah. My friends do. Oh,
Oh, yeah. He's okay. What do you play? I think like third, maybe. I don't even know.
Austin, you know your data series? Do you need Anthony to help you with data series? How do you look at series?
Wait, I want to try proving. I'm trying to understand.
Proving the n,
Like there's like
n to the n plus 1/2.
was it f and c equals n factorial a n, right?
Science Olympiad.
F and
That's what they have at Seminole or OSS.
and
Oh, middle school?
Yeah.
No, high school?
I don't know about high
to
school.
the n
Probably
over.
competitive, but I know like the middle.
Well, after you substitute that kind of stuff. I want to.
Italy, but
Bro, they're middle. Like OSS is just.
try hard.
I should have gone there. It might have been like a little bit more like less fun.
Oh, it says? You won't survive over there.
But like if I grew up around those guys, I would probably. I would have been less bummy, you know. Like, I would have been more. just a nerd then, bro. Like, it's better than what I am now. Alright, logging.
I don't think this one's right.
Can we give you answers?
Oh, I'm logging, bro.
No, I believe you got it, but I don't.
Which one?
5. Just like looking at it, looking at the numbers. I don't think it's 6.
I got you the password. That's good.
That is.
Because n factorial depends on.
Yeah, but like if you plug in, like say you plug in 2, you get 1/2, right? If you plug in 2 here, you get 1 in like awesome.
Where you plug in 2?
Or is the radius of convergence like less than that? Maybe that's why.
Yeah. 1 over.
I did not solve for the radius of convergence.
Wait, Daniel, did you finish the FR2 for free mode?
It's not Monday. Monday.
Courses and quizzes that let you dive deep into the topics like the ones that.
Let's do it at 8 a.m.
We had to just do it over the weekend, but I'm not trying to do that.
It's actually right.